Hello, everybody. So today we're going to start with the Kubernetes introduction. Yeah. So here we go. We're going to start with the Kubernetes introduction. So before we start with the Kubernetes, I just wanted to give you a brief introduction about what Kubernetes is all about and what is the agenda of this today's presentation. So today we're going to understand the Kubernetes overview and what is Kubernetes is all about. We can understand how to install the Kubernetes, what are the different architecture of the Kubernetes is there, and how the cluster has been scheduled and with the different components. So those are the things we're going to understand, and we'll understand how the components are scheduled, how the key components are they communicate with the Kubernetes master and the node, so how they communicate with each other. So those are the things we're gonna talk about, and also we're gonna learn about the Kubernetes setup. We'll see how the Kubernetes master and the node setup are done, or what are the prerequisites are there. So these are the few things we're gonna cover up today in the introduction. And we'll also understand the Kubernetes images, the Kubernetes, the pods and replication controller, the basic things we're gonna understand. And then if there is some time, we'll talk about the Kubernetes commands and all. And that's the advanced thing we're gonna do. But before that, the first thing is the Kubernetes introduction. What is it about Kubernetes is all about? So Kubernetes is nothing but Kubernetes is a kind of a free and open source container management tool hosted by the Cloud Native Computing Foundation, CNCF. This is also known as a kind of this is a kind of a this was developed at Google, and to manage the both long-term processes and batch jobs, and which was earlier been done by the separate systems. So there are multiple systems which were previously designed to work on the batch jobs and which was handled by different processes. But what Kubernetes does is that Kubernetes they comes with a kind of a capability which does the kind of automation of the deployment. It helps for the scaling of the application, and then the operation of the application, the containers across the clusters and all. So that was one of the major reasons behind using the Kubernetes. Previously there was a batch jobs which are running in a multiple systems, so you have to monitor all the systems, you have to take care of the scalability, and there were a lot of challenges which the previous systems used to have mostly on the on-premises. So Kubernetes came up with the solutions. It designed a kind of architecture which kind of helps for the automation of the deployment. You can scale your application as when required. You just have to upgrade your the node size and the cluster size, the pods and all. So that you can do. And it's a kind of a centric infrastructure. The infrastructure is completely centralized. You can manage all through your admin portal and all. So that you can do. And also it can be scaled across multiple and the cloud providers like the GCP, Azure, and IBM, Alibaba, and there are multiple cloud service providers are there. So they already have the major cloud providers. The Kubernetes is used by everybody, all the cloud service provider. So that's another advantage you have. You can use Kubernetes in any cloud service provider. You can also kind of create a hybrid platform with your Kubernetes as well. So that's one of the major advantages of using Kubernetes. You can create a multiple containers. You can manage those containers as when required, and you can define this container size. So that's one of the major reason behind using Kubernetes. Now, what are the different features of the Kubernetes? You might ask. It helps for the continuous development as well. Now, it also helps for the integration. Like you can also containerize your infrastructure. You can auto scale your infrastructure. You can define your scaling metrics. What you can do is that you can create suppose you have a kind of resource utilization is very high, but you can define, you can create the density for those utilization. You can understand what kind of infrastructure do you need for your ongoing application, and how you can create them things. So you can predict your infrastructure as well with the Kubernetes. And then you can create a loosely coupled infrastructure where each component can act as a separate unit. That you can do, and then your environment can have different development, testing, and production. That you can do. You can use it in a Linux, in a Windows, when you even do whatever in a Mac, whatever you want. You can use the Kubernetes services. So that's one of the advantages you have using Kubernetes. And one of the major key components of Kubernetes is that can run on the clusters and the physical, like as I said, it's physical and the virtual machines infrastructure. It's a hybrid platform. You can do it, and it also has a capability to run the applications. Like it has a capability of running the applications on a kind of moving from host-centric infrastructure to container-centric infrastructure. So that's the advantages you have. in the and the Kubernetes. Now, I'll take you to the what is the Kubernetes, the history of the Kubernetes and all. The Kubernetes was first released in the year 2014 by Google. As I said, it was first developed in the Google, and the developers, they created a tool for like the automation of the deployment and the scaling and the management of the containerized application. That's the reason Kubernetes was created, and it has become kind of it's a very popular application. It's open source project, because it's very simply it can be simply downloaded from the internet, and you can download it and you can easily integrate it with your cloud computing services. You can integrate it with your on premises and all, so you can do all those things. And the one thing I liked about the Kubernetes is the document. If you go to the Kubernetes side, you can find all kind of document, which is very the community it's at the developed community, and the community can support you anytime as you required. That's one of the major advantages of using Kubernetes. Now, you guys might asking, like, what is a Kubernetes? Why we need a Kubernetes? Kubernetes is nothing, but it's a kind of a container. A container is nothing. Again, a container is nothing, but it's a virtual machine that is running on a single physical server. Now, it can container, it provides a kind of a complete, it has a kind of a complete operating system. It has all the application libraries, your files, jar files, your bin files, all the files are there, and that is required to run these software applications. It's just a virtual machine, it can be configured to your complete operating environment for your container and all. As I said, the features of the Kubernetes is a kind of automation. The main reason of using Kubernetes is like the automate the process of creating, deploying, and managing the monitoring the containers. It helps the developers to focus on the primary task, which is like writing the code and then developing the code. Kubernetes, it does all the work for them. It takes care of the deploying, it takes care of the automation, the process of creating kind of images and everything. So Kubernetes take care of all those things. Kind of the automation is very important today, because most of the developers, they don't want to spend a time on the automation, and they don't want to do the kind of integration and all those things. So Kubernetes does all those things for them. So automation also allows the developers to scale their application. Like as when you need the scaling of your applications, the Kubernetes will take care of that. So that's one of the major features of using Kubernetes. And the Kubernetes, it supports many tools that makes it easy for the developers to deploy, scale, and manage the application. Scalability is one of the major features of using Kubernetes. Kubernetes can be easily scaled up or down to meet the requirement, for the cloud-based service providers. Suppose you are using Azure. So in Azure, you have the AKS services. So AKS services can be scaled up and down as per your requirement. You can automate it. You can do it horizontal scaling and vertical scaling. You can add multiple machines. Horizontal scaling is nothing, but it's a kind of an adding one or more machines to a cluster to increase the number of the containers. And Kubernetes architecture is highly scalable. I'll show you the Kubernetes architecture as well, how the architecture works, and the different components of the architecture and all. Yeah, so I'll show you those things. As Kubernetes is completely free, it's an open source project. It can be used by many cloud providers to run the container-based workload. So it can be used. You don't have to kind of pay any licensing fee. You don't have to pay any kind of enterprise licenses. There is no recurring cost involved when running using Kubernetes. You can run it on-prem. You can use in a Windows machine. You can use in any kind of which can support Kubernetes. So it's a completely an open source project. You just need to download it and use it. You just need to know how to use it and integrate it with your ongoing applications and all. Kubernetes is highly secure. It has all kind of security concerns, like the multiple authorization authentication protocols have been easily implemented in Kubernetes. So they are kind of the demand for the containers has been increasing, and Kubernetes can support any kind of security features which are like being easily integrated in the companies like Google, Netflix, Amazon, or Azure, or Microsoft, anywhere. So Kubernetes can they use the kind of security features of all the highest platform in all this platform. Now, there are multiple tools are available for the Kubernetes. You can use the different tools to monitor how the Kubernetes jobs are done. So you can use Heptio Arc, New Relic. You can use the Prometheus, CloudWatch, Grafana. I use Grafana, so I'm very much comfortable with Grafana. It helps to monitor my Kubernetes clusters, how the clusters, the size of the clusters, and I can generate my report from the clusters, and then I can present it to the management if I want. So I use Grafana. I find it very useful. CloudWatch is also in Amazon services. I try to use it sometimes back. It was also very kind of It gives you kind of commercial, it's a commercial services. Again, you can monitor your reports and Kubernetes clusters as well, so. I'll come into the Commvault Kubernetes backup. Let me just go you and show you the Kubernetes architecture for some time, and then I'll come into these slides later. See, this is the kind of overall architecture of the Kubernetes. You have a master node, you have a node, and then are connected to the internet, and then you have this thing. So how it is connected is that, like, I'll just explain you the things. Kubernetes cluster, you have Kubernetes master in the master. This is the master. So master is connected to the API, and the kube CTI, it's a CLI command which does the authorization authentication, and then through the API, you create the scheduler, you control manager, you have a distributed storage. Now, the control manager, what it does is that control manager, it might have a Linux machine, you might have you have the Kubernetes nodes are connected with the control manager. Now you have a Docker and a kubelet, which is connected, and then you have Kubernetes proxy out here. The Kubernetes master manager, like etcd is nothing but it stores the configuration information, which can be used by any of the nodes in the cluster. So that's etcd. It's not mentioned over here, but let me, for your kind of information, etcd, it's like here, it has to be there, it's not mentioned. Now we have a kind of API, that this API server over here is API server. This API server is nothing but it's a Kubernetes and an API server. It provides all kind of operations to the cluster through the API, using the API. So API server, it implements an interface, which means that different tools and libraries can readily be kind of communicate with it. So we have a kubeconfig. Kubeconfig is a package which along the any of the server side tool that can be used for the communicating. It exposes the Kubernetes API, the kube config. So you use the kubeconfig to communicate through the API. And the use of the control manager, the use of the control manager is that the control manager, this component is kind of responsible for all of your collectors, and then regulates the state of the clusters, and it kind of performs the task and all. So in general, it can be considered that it's a kind of a daemon which runs in the kind of non-terminating loop and is responsible for collecting and sending the information to the API server. It's kind of getting the kind of a sheer state of cluster and then make the changes to being the current state. So it takes care of the kind of desired state of the server. So the server is a kind of a share state. It's a kind of it makes the changes to connect to share state, and that's use the controller all about. Now the controllers are they're kind of replication controllers, kind of endpoint controllers. They have a namespace controller, and then they have a kind of service account controller as well. So that is not mentioned over here, but yeah, just for your understanding, you have a different kind of controllers to handle the nodes and the endpoints as well. And then we have a scheduler. So what scheduler does is that it's a kind of one of the major components of the Kubernetes master. It's a kind of it's responsible for distributing the entire workload. It's responsible for tracking the utilization of the working load and of cluster nodes, and then placing the entire workload on the resources which are available and which accepts the workload and all. In other words, you can say that the mechanism responsible for the allocating the pods to the available nodes, and the scheduler does all those things. It schedules the workload according to the availability of the workload, availability of the nodes and the pods available right there. And the scheduler is responsible for the workload utilization and allocating the pods to the new node as well. That's the use of the scheduler. And now we have the node. What node does is that node is a kind of before I come into the node has a multiple components. It has a Docker, it has a kubelet services, and it has a kind of a Kubernetes proxy services as well. So yeah, this is a proxy. Yeah, Kubernetes kubelet and Kubernetes proxy services. Now let me start from the Kubernetes node component. The Docker, what does is that Docker, the first requirement of each node is a Docker. A Docker, it helps to running the encapsulated application containers. They help to kind of which are relatively isolated. They help us to encapsulate those applications, and then relatively, and they create a kind of a lightweight operating environment. So that's the role of the Docker. And the kubelet services, when I talk this kubelet services, what is there? It's a kind of a small services when each node is responsible for kind of relaying information to and from the control plane services. It interact with the etcd store to read the configuration details, and then it helps us to write the values as well. So it's a kind of a communication process with the master component to receive the commands and work. So this is nothing but this kubelet is trying to communicate with my master node to see how they are communicating with each other. It helps to receive the commands and the works. The master will command through the kubectl, and the kubelet will try to receive it, to understand how the information is being related and how to and from the control service plane. So it does that thing. It's trying to communicate with each other. It also kind of responsible for maintaining the state of work and the node server as well. It manages the network rules and the port forwarding, etc. So whenever the communication is happening, it look for the ports and all, and how it will try to communicate with the different kind of Docker pods and all. So these are kubelet services. So over here there are two nodes. So each node will have a kind of kubelet services, and then it has a Kubernetes proxy service. This is a proxy service. So proxy service, what it does is that it's a proxy service which runs on each node, and it helps to making the services available to the external host as well. So suppose my external host is there, they're trying to communicate with that. The proxy service will make it available to the external host. It kind of helps, for forwarding the request to the correct containers, and capable of performing the primitive load balancing. It's a kind of a load balancing thing. Proxy, it's connected through internet. It helps for the load balancing, and it's a kind of something accessible at the same time with the different isolated as well. So it manages the pod on the node as well, volume, secret, creating a new containers, health checkups, and all those things. So proxy services, it has multiple functions. It takes care of the entire the primitive load balancing. It takes care of the health checkup. It takes care of the creating the new containers, and also how you create the new containers. So this is how the proxy is created. You have a new pod over here, then you have a new container. So proxy helps us to manage the health checkups and all those things. So proxy services does all this. It's a kind of a service available to the external host as well. Suppose I'm sitting outside, and then I'm trying to connect, and then have a capability of performing the accessibility. It helps with predicting the accessible, how it will be connected and all. That's a different thing, but it's kind of a predicting the accessibility at the same time. So this is how the Kubernetes architecture looks like. It's a very simple architecture. There's nothing much. There is a master which is connected to the scheduler, control manager, and distributed storage. Distributed storage is nothing but it helps with storage the distribute the storage from one to another, one across to another thing. So, and then you have a kubelet proxy. Yeah, this is a simple architecture of the Kubernetes. All right, let's come into the presentation. Now, the other thing is that, yeah, the other thing is that we have a kind of Commvault Kubernetes, Commvault Kubernetes backup is one of the important ways to secure your cloud. Like suppose you don't know your clusters might get deleted, or there might be kind of a disaster. So what you do is that you have to back up all your data. So Kubernetes is a kind of highly available system which helps you to not only recover your failed data, it helps you to make sure that you doesn't delete deleted data can be recovered easily. If you're using a public cloud like Azure or GCP or AWS, you can use the cloud backup to back up your Kubernetes cluster. So you have to do all the setup over here there and the disaster recovery, and integrate your Kubernetes AKS in the AWS, not AWS, Azure. And if you're using Kubernetes on AWS, you can use the AWS Fargate services to create a cluster for the backup. However, if you're using a Kubernetes on your own data center, like suppose you have your own premise data center, then you can use the Commvault to back up your Kubernetes cluster. So that's the use of Commvault Kubernetes backup. Commvault, again, Commvault is an open source product, and it's used to back up and restore your Kubernetes clusters as well. Why you have to back up all your Kubernetes clusters? First of all, you can restore your data easily if a failure occurs. If there might be a kind of failure, there might be a kind of disaster recovery, there can be a disaster, there can be a natural disaster, there can be anything, electricity failure, anything, it can happen, anything, there might be a fire in your data center and all, there might be any mishaps. So what you can do, you can restore your data easily through that. And secondly, you can use the Commvault backup API to automate your backups as well. You can do the automation as well for the backup as well. That's one of the best things you have. You can automate your backup. You don't have to do it manually, but you can automate it through the API. Third, you can create a daily backup schedule. Yeah, you can create a backup schedule to ensure that your data is backed up every day, every hour. You can schedule the hour at 12 o'clock, 12 p.m. at noon, whatever time you want. You can do a kind of data is backed up. Usually a daily backup schedule can be created. Fourth, you can also restore your data from the Commvault backup. So you can, if you want to restore your data from the Commvault backup, you can easily do that. So that's one of the best services is there. So in conclusion, Kubernetes is a free and open source project. It's used by many cloud providers. It's a free tool. You don't have to pay anything licensing fee for that. It's a kind of a recurring cost. There's no recurring cost out of it. You can save a lot of money by using a free version of the tool. So that's all about Kubernetes introduction. So we'll do the next. We'll do some hands-on in the next session, and we'll start shortly. Okay. I hope you enjoyed this video, and if you have any doubts, you can post on the comment section. Thanks all.